Welcome to my IB Chemistry exam preparation exam tips for both standard level and higher level channel. Today I'm going to cover topic number 1, stoichiometric relationships. We will learn together how to solve Avogadro's constant problems. Through our lesson, we will apply on some past paper questions, problems, which we found in paper number 1 for Avogadro's constant. And of course, here we need to remember that it's not allowed to use the calculator. So we will apply on all calculations step by step without the use of any calculator. In order to start with Avogadro's constant and to apply on Avogadro's constant problem, the first thing we need to remember two essential triangle rules we will be using while applying on our calculations. The first triangle rule, which is this one, number 1, it shows the relationship between the mass, mole, and molar mass. Of course, if you want to calculate the mole number, you need to take the mass and you need to divide it over the molar mass. But if you want to calculate the mass in grams, so you will be taking the mole and you're going to multiply it by the molar mass. Continuing with the second triangle rule, which is a very important triangle for Avogadro's constant problems and calculations, into which if you want to calculate the molecules number or the particles number, you will be applying on mole and you need to multiply it by Avogadro's constant, which equals to 6.02 times 10 to the power of 23. But if you want to calculate the mole number, and inside the question the molecules or the particles are given, so of course you need to divide the molecules number or the particles number by Avogadro's constant. As a small summary, we have inside this triangle the main rules that we will be using while applying on some past paper questions. Of course, the first one, mole equal mass divided over the molar mass. Number 2, number of molecules or particles. Of course, it will be equaling to the mole number multiplied by Avogadro's constant. And inside the past paper, they may ask you also to calculate the number of atoms. When talking about the atoms number, here I'm specifying all atoms presented. So you will take the molecules number and you need to multiply it by the total number of atoms presented after counting how many atoms do you have in the whole molecule or compound given. So if I'm going back another time to rule number 2, I will find that the number of atoms, it will be equaling to the mole multiplied by Avogadro's constant and multiplied by the total atoms number. Inside past paper questions for paper 1, since it's not allowed to use calculator, so you can simply use 6 times 10 to the power of 23 instead of 6.02 times 10 to the power of 23. And this is what I'm going to do while applying on the calculations. I'm going to circle this rule as it is so essential and it is important to know it, and we will see how we are going to apply on it for the past paper questions. We will start with the multiple choice questions, and in each time there will be an idea and we will see how can we apply on calculations. How many atoms are presented inside 0.1 mole of platinum chloride, and you've got between brackets the ammonia by 2. When talking about how many atoms, so I'm talking about all atoms which are presented inside my compound. So let's start with the rule. So the number of atoms, you will take your mole number and you will multiply it by Avogadro. As I mentioned earlier, no need to write 6.02 to simplify the calculations, of course. Then you're going to have the total atoms number. Now we will simply apply. The mole number presented, it is 0.10, multiplied by 6 times 10 to the power of 23, multiplied by the total atoms number presented inside the compound given. So I need to count. I've got 1 platinum plus 2 Cl plus, I need to remember that I have 2 nitrogens besides the presence of 6 hydrogen atoms. This 2 is for the whole ammonia, which is presented between particles, or between the brackets, sorry. So you need to take 2 nitrogens and 6. As a total number, you're going to find that you have 11 atoms. So I'm going to multiply by 11. Now we're going to continue by math. 0.1 with the 10 to the power of 23, you need to remember that 0.1, it is 1 to the power of -1. So this will become 6 times 10 to the power of 22. Since the -1, if you want to take this number, you're going to have that the decimal in this situation should be added. So -1 and the 23, the total, it will be 22. Now times 11. 6 times 11, of course, it is 66 times 10 to the power of 22. Now, it is so important to remember that inside the past paper, your final answer given as a multiple choice into a correct number of scientific, in the part of scientific notation. So in this situation, I will be writing this number another time into a scientific notation way, which is 6.6 times 10 to the power of 23. So your final answer will be the C. Now we're going to apply on more questions and more ideas. Question number 2, there is another idea for the Avogadro's constant. We will look for the difference between it and between the previous one. What's the total number of oxygen atoms? So now I'm more specific. I'm going only to count the atoms of oxygen which are presented in 0.2 mole of a glucose. So we will start now with the number of, we are specifying only the oxygen. So we need to remember each time the rule. We will take the mole, which is 0.2, multiplied by Avogadro's constant, 6 times 10 to the power of 23. And finally, we're going to have the total number of oxygens presented inside the glucose. And you're going to find that we have 6 oxygens presented. Okay, let's do some math now. I prefer to start with the 6 and 6 together, which is equal to 36 times 10 to the power of 23. And then it is multiplied by 0.2. Now the question is, how can we deal with a decimal if you have a multiply? Simply, you will firstly take the 36 and you need to multiply by 2. Then you're going to add the decimal. So 2 times 6, it's a 12. Then you have a 6 and you have a 7. Now I'm going to add my decimal. So my final answer is 7.2 times 10 to the power of 23. Your final answer, of course, it's the D answer. Here, if you look at the final answer, you're going to find that there is a 2, which is presented as 0.22. Remember that this is taken from Avogadro's constant if you take it as a whole number, since it is 6.02 instead of 6. And as I said previously, you can simplify your calculations. Continuing with question number 3. In question number 3, the question is asking about the total number of protons and electrons which are presented inside 1 mole of a hydrogen, which is a gas. Now, in this question, we have several things that we should start thinking about. When talking about hydrogen gas, so I'm talking about hydrogen as being a molecule. Since the hydrogen in nature, it's presented as a molecule, not as a single atom. The second thing, when talking about number of protons and electrons, both of are particles number. So as if the question is asking me to calculate particles another time, particles, it is Avogadro's. So definitely I'm going not to think about A or B at all. So my choices would be either C or the D. Now I'm going to count how many protons and electrons presented inside the hydrogen molecule. Talking about one hydrogen, I have one atomic number and one mass number, so the protons will equal to 1 and the electrons equaling also to 1. So the total is 2 particles. Since I've got hydrogen molecule, so I'm talking about 4 particles. Now I've got one simple step, which is 4 multiplied by Avogadro, and your final answer would be 24 times 10 to the power of a 23. Writing this into a correct scientific notation, your answer, it would be the D, which is 2.4 times 10 to the power of a 24. We've got here another question, which is in somehow similar to the number of atoms that we previously considered in question number 2. What's the number of atoms of oxygen which is presented in 2 mole of hydrated sodium carbonate? In this question, I'm going only to check that you know how to count the total number of oxygens presented. But as an idea, we already covered this idea before. So, starting with number of oxygen, I'm going to take my mole number, which is equal to 2 times 6 times 10 to the power of a 23 multiplied by how many oxygens are presented inside my hydrated sodium carbonate. I have 3 oxygens here plus 10 water molecules, so it is 10 times 1, so it's a 10, so in total I have 13. So we need to multiply by 13. Going through math, 2 times 13, it will equal to 26 multiplied by 6, and then it is multiplied by 10 to the power, so 6, and multiplied by 10 to the power of a 23. Okay, so let's do the math together. 26 times 6, it is 36. 6 and 2, it's a 12, and the 3, it's a 15. So this is 156 times 10 to the power of a 23. We're going to rewrite this number into scientific notation. So it's 1.6 after rounding times 10 to the power of a 25. So your final answer, it is actually the D. We have here another idea. In this question, we don't have the mole. What's given is the mass. So let's read it. What's the number? Another time I need the carbon atoms which are presented inside a 12 carbon of ethanoic acid, which is CH3COOH. The molar mass is given. So remember, you cannot calculate the carbon atoms if you don't have the mole. So definitely in this question, you need to start by the mole number as a first step. Remember that the mole, it is the mass divided over the molar mass. So it's a 12 over your 60. You can start thinking about how can you divide such this number. I prefer before starting dividing to simplify as possible. So I'm going actually to divide over a common number, which is 6 for both. So 12 divided over 6, it will equal for 2. Then 60 divided over 6, it is a 10. Then you can further simplify by dividing over 2. So this will become a 1 over 5. The 1 over 5, it is a 0.2 mole number. To double check that you can do the long division, 1 divided over 5, it cannot be at all divided. So I'm going to put a point, then a 10 right here. So this will become a 2. And finally, you have the 0.2 as a mole. Now you can continue up your calculations, so you can find out the carbon atoms number. You will take your mole number, which is 0.2, you will multiply by Avogadro's constant. Then you will count how many carbons are presented inside the ethanoic acid, which is equal for the 2. 6 times 2, it's a 12. Then it will be multiplied by 0.2. Then it will be also multiplied further by 10 to the power of 23. Now 12 times 2, it's a 24. Then I'm going to add my decimal times 10 to the power of a 23. I'm trying as possible to do all the calculations steps with you without the use of calculator. Continuing now with another idea, which is question number 6. Actually, this question is found in paper 1 in 2021 in time zone 1 paper. So it's from the new ideas and it needs maybe a lot of work here. Question number 6 is also considered as a challenge question, and you're going to find why. We will apply on a lot of math. Question number 6, which contains the most atoms of oxygen? So another time I need to calculate the oxygen atoms, but there are A, B, C, D, so I need to apply on 4 times in order to find the oxygen atoms and to compare. So let's start with the A. According to the question, I have the mass, so I'm going to start firstly with the mole, which is 64 divided over. Now for the oxygen, the one oxygen is 16, and since I've got that, of course this is the molar mass, so it is 16 times 2, so it's 64 divided over 32, and your final answer is 2. Now since you've got the mole number, you can continue with the second step, which is your atoms, number of oxygen. So oxygen atoms equal, you will take your 2 and you will multiply by Avogadro's another time and multiply by the number of oxygens presented in the oxygen molecule. So 2 times 6, it's a 12, and you've got another 2, so it is a 4 and a 2, so it's a 24 times 10 to the power 23. I always prefer to compare when it is given in the scientific notation. You can leave it as it is if you want. So I'm done with A. So to have a better comparison and to be able to compare, I'm going to write the final answer for A beside it, which is 2.4 times 10 to the power of a 24. Okay, now I'm going to erase A and we're going to start together with a B. We can start now thinking about B. Inside B, you actually do not have the mass as A. Instead of that, you have the molecules. So you need now to start thinking, what can I do in order to calculate the molecules number? So this is for B. Now the rule to calculate the oxygen atoms using the molecules, it will be molecules multiplied by all oxygen atoms presented. So this is a very important rule to apply on. So for the molecules, what do we have? We have 1.2 times 10 to the power of a 24, and I'm going to multiply it by the oxygen atoms as a number, so it's a 2. In this situation, the final answer is 2.4 times 10 to the power of 54. You can find that the same answer exactly is presented as A, so by default, it's not an A and it's not a B as well, since they share the same number of oxygen atoms. I'm going only to put it in case. Now I'm done, so I'm going now to continue with the C. So let's see in C. In C, another time, we have the mass, so I need to start with the mole. 64, and I'm going to divide over the molar mass of the whole molecule given. Inside paper 1, we can take the numbers of the relative atomic mass as being rounded. So this is the 3 times the 12 from the periodic table, plus 5 times 1, plus 3 times 16. So it is 64 divided over 3 times the 12, it is 36, plus 5, plus 48. Now you add 64 divided over 89. Okay, so what's the final answer? In this situation, I need somehow to do calculations. I need to calculate the mole number, so we need to apply on math. So as a long division, I'm going to divide over 89. Of course, I cannot, so I'm going to put a 0 right here. Now I need to think about the 64 and the 80 presented. 8 times 8, it's a 64, but there is a 9, so I'm going to take a smaller number, which is 0.7. I can stop right here and no need to continue, since it will help you in comparing your final answer when it is a paper 1. So it's a 0.7 mole number. Now we will take our 0.7, we will multiply by Avogadro's constant another time. Then going back, how many oxygens do I have here? I have 3. So I'm going now to continue. 6 times 3 equals to 18, multiplied by 0.7 times 10 to the power of 23. So now I'm going to continue by 18, which is multiplied by 0.7. So it's right here. 7 times 8, so it's a 6, and you've got a 5. 7 and 5, it's a 12. Then you were going to add the decimal. So your final answer is 12.6 times 10 to the power of 23. Scientific, it is 1.26 times 10 to the power of 24. So I'm going to take my final answer and I'm going to put it beside the C. We are almost done. As I told you before, this is a very challenging question and it requires a lot of calculations. You need to be familiar with these questions, especially that this question comes in 2021, paper 1. We are almost done, so I have now my D, which is the molecules is given. So we will be using the rule as A. So in order to find the oxygen atoms, I will take my molecules number and I need to multiply it by the total number of oxygens, which are 3. 1.2 times 3, your final answer is 3.6 times 10 to the power of 24. So here it's 3.6 times 10 to the power of 24. Going back to the question is telling me which contains the most oxygen atoms, so your answer it's a D. Okay, now we've got question number 7. Actually, this question is also a new question. It was in 2021 in November. The question is asking how much ethanol contains 1.2 times 10 to the power of 24 atoms of carbon, and the Avogadro's constant is given. Now the first question is to see what the question is asking me to calculate. How much ethanol? If you look at A, B, C, and D, you will find that the question is asking about the mole number of ethanol. Now the second point, what is ethanol? Definitely till now you didn't take organic, and maybe you will not be familiar with the chemical formula of ethanol now. You can Google it, or perhaps you take it before, but make sure that after finishing the whole curriculum and taking chapter number 10, you will be able to write down the chemical formula of ethanol, which would be CH3, CH2, and you have an OH. This is how inside this question, actually I've got the carbon atoms and I need the mole numbers. So if I'm going to write down the rule, now the carbon atoms, as a rule, it will equal to the mole number multiplied by Avogadro and it is multiplied by the total number of carbon atoms represented inside the molecule, which is 2. So this one is multiplied by 2. Now, the carbon atoms is given inside the question, which is 1.2 times 10 to the power of 24 equal your mole number. You don't know it, so you need to calculate it. 6 times 2, it's a 12. Multiply by 10 to the power of 23. Now you need to divide over 12 times 10 to the power of 23 over 12, 10 to the power of 23. How can we find now the mole number? So let's apply on math another time. In my opinion, it's easier for me to overcome from the decimal, which is presented above. So it will become a 12 times 10 to the power of 23. I'm rewriting the number, taking 110 from the power, and here you have a 12 times 10 to the power of 23. So definitely your final answer, it will be a 1 mole, and the answer, it's a C answer. We've got another more ideas, so to cover all possible questions presented inside paper 1. I've got now question number 8 or 9. It is another time a challenge question. You're going to find that we will be applying on math and calculations for several times. Which sample has the greatest mass in grams, of course, comparing A, B, C, and D. So in order to start, we need to have the mass. According to A, what do we have? We have the molecules number. So we need to find the mole number. Now the mole, it will be the molecules divided over your Avogadro's constant. Your molecules is 6 times 10 to the power of 25 divided over 6 times 10 to the power of 23. 6 and 6 together, taking the power above. So this will become a negative 23. So it will become a 10 to the power of 2, which is equal to 100 mole number. Now I need to calculate the mass, which will equal my mole multiplied by the molar mass of the hydrogen. We need to remember that it is a molecule and it is already given. So I'm talking about molar mass, which equals 2 times 1. And it's essentially, of course, it's essentially 1.01 given as a relative atomic mass, but we can round. So it is a 2, and your final answer is 200 gram. Okay, done with the first one. I'm going to write it beside it here. Now, for the second, it's a B. We've got the 5 mole number of neon atoms. So in order to find the mass, we will take the mole and we will multiply it by the molar mass. The mole number is 5. From the data booklet, from the periodic table, we can find the molar mass of neon. And here I want to mention that inside paper 1, the periodic table is of course attached with you. So for paper 1, it's not the data booklet. You're going to find it inside your external. You will find the periodic table with the relative atomic mass. So we need to check what is the molar mass of neon. And actually, the molar mass of neon is a 20 after rounding. So your final answer is 100 gram. I've got now the C. Another time I have the atoms, so it's the same as A. So the mole, I'm going to write the 100 gram beside the B. So I will take my atoms number and I'm going to divide over 6 times 10 to the power of a 23, which will be 12 times 10 to the power of a 23 divided over 6 times 10 to the power of a 23. 12 divided over 6, the final answer is 2 as a mole number. Now we have the mass. You will take your 2 and you will multiply by the molar mass of silver. Another time from the periodic table, the molar mass is 108. And your final answer is 216. So I've got C now, which is 216. Now for D, it's the easiest since the mass is already given. It is multiplied by 10 to the power of 2, which is equal for 170 gram. So we are done now. We've got the masses. So the greatest mass is obvious for the silver, and the answer is a C answer. We have now another idea which is also important, and I'm going to give you the way of thinking and how can you answer this multiple choice without taking from you a lot of time while applying on paper 1. Which sample contains the largest amount in mole of oxygen atoms? Inside this question, the given is the mole number of the whole molecule. So you've got 0.2 mole of P2O5, 0.3 mole of oxygen, 0.4 of ethanoic acid, 0.8 of water. So if you need to calculate the mole number of a specific element presented in the whole molecule, and the whole mole number is given, so simply you will take the 0.2 as a whole mole number and you're going to multiply it by how many oxygen atoms are presented. So you've got 5. So now 0.2 times 5, it's a 10 and a decimal, and you are done. You will do the same for B, and you will take your whole mole number, you will multiply it by how many oxygen atoms do you have, and your final answer, it's a 0.9. We have the C now, which is 0.4, and I'm going to multiply it by oxygen's atom, it's a 2, So your final answer, it's a 0.8 mole number. Finally, I have the D, which is 0.1 multiplied by 1. So your final answer is a 0.8 mole number. So the largest, it is of course an A. Here you need to remember that the ratio of atoms presented inside the molecules is a mole ratio. So I can say, according to the empirical formula lesson, that I have 2 mole of phosphorus with 5 mole of oxygen inside the first molecule. So in such these questions, simply take the mole number of the whole and multiply it by the mole number or the atom's number presented inside the molecule. This will help you to reach your final answer, which is the mole of the oxygens presented. I've got now another 2 multiple choice ideas, which are 11 and 12. So to finish our session for today, which amount of the following compounds contains the least number of ions? So I've got here an idea which is based on the ions number. Now the big question is, how can I apply on number of ions? The rule of number of ions is very similar to the rule of number of atoms. So you need to take the mole and you need to multiply by Avogadro's constant, and you need to multiply by the number of ions which are presented inside the ionic compound given. So the big challenge here is only to be able to count the number of ions. Maybe some students got difficulties while talking about the number of ions and comparing it with the number of atoms. So let's see how can we apply on such this question. So let's start with A. To find the number of ions, I have 2. I will multiply it by 6 times 10 to the power of 23 times. I need to think about how many ions are presented inside the sodium hydroxide. Remember, sodium hydroxide. So it's made up of 2 essential ions. I've got an A positive and I have the OH negative presented. So the total number of ions which are presented here, it's 2. But if the question is asking you about the total number of atoms, it's actually 3 atoms. I've got 1 sodium, 1 oxygen, 1 hydrogen. But as an ion, the OH together is considered 1 ion. So 2 times 2, it's a 4. 4 times 6, it's a 24. Multiplied by 10 to the power of 23. I'm going to rewrite it into scientific notation. It's up to you actually, but I prefer that to rewrite it into scientific. For the B part, I've got the mole number multiplied by 6 times 10 to the power of 23. I'm going now to count the number of ions which are presented inside my ammonium chloride. Another time, I have 2 ions, ammonium, and the second one is the chlorine, so it is multiplied by 2. So 6 times 2, it's a 12, and I'm going to rewrite it into scientific notation as a final answer. Now continuing with C, it's a 2 multiplied by 6 multiplied by 10 to the power of 23. Try to think about the number of ions here. Calcium chloride. So what you've got? How many ions do you have? Okay, let's see. Ca, Cl2. You have 1 Ca positive 2, and you have the chlorine as well, but I've got here 2 Cl negatives. Remember that to count all the ions. So in total, it is 3 ions here. So it's multiplied by 3. 2 times the 3, it's a 6. 6 times 6, it is 36. So I can rewrite it into scientific times 10 to the power of 24. Of course, it's 36 times 10 to the power of 23. I'm rewriting it into scientific. D, you have 1 multiplied by 6 multiplied by 10 to the power of 23 and multiplied by the total number of ions. So I have 2 aluminum ions and I have another 3 oxygen ions. So I've got 3 and another 2, so your final answer is 5. So here 5 times 6 and your final answer it's 30 times 10 to the power of 23. And it will be equal to 3 times 10 to the power of 24. So, which of the following compounds contains the least number of ions? Definitely the smallest, it's the B, which is 1.2 times 10 to the power of 24. I'm going actually here to help you in doing something which is so important and will help you in multiple choices. In this question, since you've got Avogadro's constant as being a constant number for comparison, so there is no need to include it in your calculation. Yes, it's not important to include it here. So I'm going now to do it another time, but in a simpler way. So this is considered a tip that will help you in paper 1. So no need to use 6 times 10 to the power of 23. It is presented each time, so it's a constant number. So for A, I'm going only to take the mole multiplied by the number of ions. So it's a 2 equals 4. Another time, 1 multiplied by 2 equal 42. 2 moles multiplied by 3 ions, and we already count these ions before. So your final answer is 6. Finally, 1 multiplied by 5, and your final answer is 5. So your answer, it's a B. I'm going now to give you the last question, which is also related for the ions presented inside water, to make sure that this idea is already understood. Which of the following will have the highest amount of ions when you dissolve it inside water? So, number of ions, I'm going to apply it in the simpler way. So I'm going to take my mole number and I'm going only to multiply by the number of ions which are presented inside my ionic compound. So starting with A, 2 times. How many ions do I have here? It is Na positive plus your Cl negative. So 2 times, yes, that's right, it's a 2. So your final answer is 4, B. I have 1 multiplied by calcium chloride. We already took this ionic compound previously in 11. If you remember, we have Ca positive 2 plus 2 Cl negative. So your final total ions will be 3. And here you've got a 3. See, you have it 2 times. Oops. In this question, they are giving me C6H12O6. This one, is it an ionic compound? It's actually not an ionic compound. So it will not split into ions. So there is an idea here. Will not split into ions. So I cannot think about it at all. Talking about ions, talking about the type of bond, ionic compounds, molecular compounds, these ideas are all presented inside chapter number 4. So you will be familiar on ionic, covalent, the difference between them, and you will know why is C considered as being a molecule, the type of bond presented, the intermolecular forces. But for now, of course, this is not an ionic. It's a molecular and it will not split at all into ions. So definitely this is incorrect. Finally, I have half multiplied by, I have 2 sodium ions, and I have 1 oxygen. So in total you have 3 and your final answer is 1.5. The highest amount and your final answer is an A. This was the last multiple choice for our lesson. Through all these multiple choices, you will be able to answer the past paper practices for Avogadro's constant without the use of calculator. See you in another video.